The Aurora Borealis, otherwise known as the Northern Lights, is a vivid demonstration of Earth's magnetic field interacting with charged particles from the Sun. It's also beautiful and worth braving a cold night out when visiting the high northern or southern latitudes. Auroras are centered on the Earth's magnetic poles, visible in a roughly circular region around them. Since the magnetic and geographic poles aren't the same, sometimes the auroras are visible farther south than one might expect, while in other places it's farther north. Aurora displays are created when protons and electrons stream out from the solar surface and slam into the Earth's magnetic field. Since the particles are charged, they move in spirals along the magnetic field lines, the proton in one direction and the electrons in other. The air is made up of largely nitrogen and oxygen atoms. With oxygen becoming a bigger component at the altitudes auroras happen, starting at about 60 miles up and going all the way up to 600 miles. When the charged particle hit them, they gain energy. Eventually they relax, giving up the energy and releasing photons of specific wavelengths. Oxygen atoms emit green and sometimes red light, while nitrogen is more orange or red. Satellites can take pictures of the aurora from Earth's orbit, and the images they get are pretty striking. In fact, auroras are bright enough that they show up strongly on the night side of the Earth even if one were looking at them from another planet. The International Space Station's orbit is inclined enough that it even plows through the heavenly lights. Most of the time, nobody notices as the density of the charged particle is so low. The only time it matters is during particularly intense solar storms when radiation levels are high. At that point, all the astronauts have to do is to move to a more protected area of the Voyagers 1 and 2 were the first probes to bring back pictures of auroras on Jupiter and Saturn, and later Uranus and Neptune. Since then, the Hubble Space Telescope has taken pictures of them as well. Auroras on either Jupiter or Saturn are much larger and more powerful than on Earth, because those planets' magnetic field are orders of magnitude more intense. On Uranus, auroras get weirder, because the planet's magnetic field is oriented roughly vertically, but the planet rotates on its sides. That means instead of the bright rings you see on other worlds, Uranus auroras look more like single bright spot, at least when spied by the Hubble Space Telescope. Occasionally, the auroras are visible farther from the poles than usual. In times of high solar activity, the southern limit for seeing auroras can go as far south as Oklahoma and Atlanta, as it did in October 2011. A record was probably set at the Battle of Fredericksburg in Virginia in 1862 during the Civil War, when the Northern Lights appeared. Many soldiers noted it in their diaries. Northern Lights look like fire, but they wouldn't feel like one. Even though the temperature of the upper atmosphere can reach thousands of degrees Fahrenheit, the heat is based on the average speed of the molecules. After all, that's what temperature is. But feeling heat is another matter. The density of the air is so low at 60 miles up that a thermometer would register temperatures far below zero where aurora displays occur. Auroras are relatively dim, and the redder light is often at the limit of what human retinas can pick up. Cameras, though, are often more sensitive, and with a long exposure setting and a clear dark sky, you can pick up some spectacular shots. The most difficult problems in solar physics is knowing the shape of a magnetic field in a coronal mass ejection, which is basically a huge blob of charged particles ejected from the Sun. Such coronal mass ejections have their own magnetic fields. The problem is, it is highly impossible to tell in what direction the coronal mass ejection field is pointing until it hits. A hit creates either a spectacular magnetic storm and dazzling aura with it, or a fizzle. Currently, there is no way to know ahead of time.